Hey, we have here today another integral. This one's from the MIT Integration Bee 2022 Finals, problem number 1. We have the integral of this whole giant radical here with a whole bunch of trig functions. So let's get started with this. At first, this was pretty intimidating because it's such a long expression with the different angles, but a couple things I do notice. It's nice that we have the same angles on all these corresponding functions, right? So maybe we can make use of that everything's going to be 20, 21, 22x. And also the coefficients, like we have 3, 3, then all these are 1s, so that's not bad. Okay, so I think what needs to happen is we need to get some kind of simplification. We'd like it if this somehow was a perfect square, but I think to simplify this, we're going to need to do some algebra and maybe use some trig identities. Okay, so to start with, I'm just going to use this formula for squaring a trinomial a plus b plus c. And so when we square it out, we have this formula. And just notice that's what we're doing up here twice. Like if I'll call sine of 20x my a, we'll call this our b, and I'll call this my c. And of course, we can do the same thing over here with cosine. I can just call this d, e, and f. And of course, this is the same formula we have here. I just wanted to write it out this way so we're clear that we're doing the same thing for our cosine functions. And the thing I want to focus on at first here is like just these squared terms. And the interesting thing here is like, let's just kind of look at like one example. So if I look at a being sine of 20x, if we look at sine of 20x, but that's going to be squared. And then let's just use our d. D is going to be cosine of 20x squared. Well, this is just sine squared plus cosine squared, so this is going to be 1. Then like doing the exact same thing for our b squared and e squared terms, so a little different. We get a 3 on the coefficient, so we're going to end up squaring this. We're going to have 9 sine squared 21x, and then we're going to have the same. We're going to have 9 cosine squared 21x. Then of course factor a 9 out, and we have the same identity. Sine squared plus cosine squared is 1, so this one's going to just be 9. And then for this last term, c squared plus f squared, and of course this is 1, just the same as the first one. So what we can do is just add these numbers together, and we get for this expression that we boxed in red, this whole piece is going to be just 11 right here. So now coming over here, let's see if we can do something kind of similar, maybe not as easy, but maybe let's just focus on 2ab plus 2de and see what we have when we write those out. So 2ab, so we're going to have 2 times sine 20x times 3 sine 21x. I'm just going to take this out front and write this because we have 2 times 3. I'm just going to write a 6 out here. And then for our 2de, it's going to be the same coefficient, so we're going to have a 6 out front, and then we're going to have, let's see, cosine 20x, and our e, we're going to have cosine 21x. Well, now from here, just kind of ignoring the 6's for a second, just looking at this piece and this piece, you may actually recognize this as the angle difference formula for cosine. So let's just look at that really quick. Okay, so we have our angle difference formula for cosine, and notice it's exactly in the same form as what we have here, with just 6's multiplied through on everything, so that's not going to change it. So kind of working backwards from this, if our a is 21x and our b is 20x, we can put this back in our cosine formula over here on the left. But the beautiful thing with this 21x minus 20x, this is just actually x. So we can write this whole thing over on the left, we can write this as 6 cosine of x. So that's some pretty good simplification right there. And the nice thing is we can do the same exact thing for these other 2 pairs right here. And let's just do that really quick. Okay, so we have our next 2 values down here to the bottom. And then just coming over here to the left, this one's exactly the same as this one. So this is going to end up being 6 cosine x. But this one we have 22x minus 20x, so this one's going to be 2 cosine 2x. So what this is going to reduce to, we have our 11. We have a 6 cosine x. Then we're going to have another 6 cosine x here. And this last one's just going to be plus 2 cosine 2x. So at this point, I think we're ready to put all this stuff back in the radical and see what we have. So we have this back under the radical. I'm not ready to deal with the integral yet, so I don't care what that was. We still want to do some more simplification here. And just to be clear, by adding 6 cos x and 6 cos x, that's how I get the 12 cos x here. And I made a mistake. This is supposed to be the angle here is supposed to be 2x. And let's look at this. So what I'm going to do is let's use the double angle formula for this. So the formula that I want to use for this is cosine 2x is going to be equal to 2 cosine squared x minus 1. The reason I'm doing that is because I want to factor this, and so we already have a cosine, so I'm going to use the form with cosine. But notice this is going to get us back to just the single x for our angle. Okay, so let's just plug this value in for cosine 2x and see what we have. Okay, so we have this in here, and what I want to do next is I just want to distribute in this 2. So just rewriting the radical again. So when we distribute in 2 times 2 cosine squared x, we're going to have 4 cosine squared x. Then we'll keep our 12 cosine x. And then for this last term, we're going to have our 11, but then when we distribute in 2, we're going to have 11 minus 2. It's going to give us a plus 9. But now we're in good shape to factor this thing, and this is going to be a perfect square. So what I can do now is just write this as 2 cosine of x plus 3 all squared. Just notice if you multiply that out, you get the same thing here. But because we're inside the square root, essentially this is going to cancel with this, but we want to have an absolute value for the moment. So this is going to give us 2 cosine of x plus 3. But you'll notice even when cosine of x is minus 1, this is still all positive. So I can just remove my absolute values because this is always going to be positive. And now I think we're ready to put our integral sign back in. So let's just integrate this thing, which is a really easy integral after all that simplification. So we're going to have, integrating this, we're going to have 2 sine of x, and then integrating 3, we're just going to have plus 3x plus c, and that's it. So I think it was actually a pretty fun problem, and it's kind of interesting that we were able to take this huge thing here and we were able to simplify it all the way down to just this and do such an easy integral. So we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.